Alright, so welcome back to question number 5. We were just about to move on to questions 6 and 7, but before we actually work on them, we're going to have to write an equation for the price of a Lord of the Rings ticket. That's not a problem. But on number 7, we're going to have to use that function in order to come up with the price of the movie ticket in 2012. So in order to accurately predict that using our equation, I want to store that number in the calculator, that growth factor. So let me go back to the calculator here. And since this is 1 plus r, I'm just going to go ahead and add the 1 back to it. So plus 1. And now let's just store that as maybe a, since that's the closest one that's to it. Hit enter. And so now I'm just going to use this in my little equation. So moving on to question number 6. We want to write the function. So the function is going to be y is equal to the original price, which is $5.65, times 1.03308-ish raised to the x power, where x is the number of years after 2001. And remember, for this part, we're actually just going to use what we stored in the calculator. So that's what we're going to do on 7. So Peter Jackson and his friends are making the first Hobbit film. There's going to be 2 of them. The first one's going to be released at the end of 2012. So using this model here, we're going to predict the price of one of those movie tickets in 2012. So we need our x value, and that's 2012 minus the original 2001, which is of course 11. That's our x value. I'll just plug it into our function there. Y equals $5.65 times 1.03308-ish raised to the 11 power. So we need our calculator up here again. Move it out the way. So I can just go ahead, since that number is already in the calculator, raise that to the 11th power, and now multiply that times $5.65. And I can see that the price of the movie ticket is going to be, according to this model, $8.08. Who knows if that's actually accurate or not, because I haven't been to movies in a while. Anyway, so let me pull up that timer again. Alright, so we still have time. Move on. Question number 8. Jacob deposits $100 into an account that earns 100% annual interest. Good luck on that one. Compounded continuously in 1 year. How much money is in Jacob's account? So you should recognize this, or hopefully you do, as the setup for the definition of E. But in that original definition, it was just $1 that you put into an account. But it still works the same way. And since this is compounded interest, continuously compounded interest, you're going to use the Pert model. So the amount in your account is equal to the principal times e to the RT. So our amount is $100 times e to the 100% interest, which is just 1, and our time is 1. So all that to the first power. So basically this is 100 times e. So 100 times 2.718281828, etc. And this multiplying times 100 is going to move this decimal place over 2 places. So our dollar amount is $271.80, not 2 cents, but since I have to round it up, 83 cents. Tons of money.